Lesson 2.3.1 Introducing Systems of Equations. In this video, we will write systems of equations to represent problem situations. Vocabulary. So we got three vocabulary words here, or phrases in this case. Systems of linear equations. System of linear equations is when two or more linear equations define a relationship between quantities. Consistent system or consistent systems are systems that have one or many solutions. Inconsistent systems are systems with no solutions. Types of graphical solutions to systems of equations. So we have three different types of outcomes. We have the case where our two lines are parallel to each other. Okay. A solution is when the lines cross each other, so since they don't cross, there is no solution. Okay, so when you have parallel lines, you're going to have no solutions. The second case is when the lines are the same. So if you look here, you can see a red line and a black line right on top of the red line. That's infinite solutions, okay, or many solutions. And then the third one is the case where the two lines intersect, okay, and the point for which they intersect at is the solution. And so you would have one solution because they intersect at one spot. All right, write a system of linear equations to represent each problem situation. Define each variable. 1A. Marcus and Philip are in the robotics club. They are both saving money to buy materials to build a new robot. Marcus opens a new bank account. He deposits $25 that he won at a robotics competition. He also plans on depositing $10 a week that he earns from tutoring. Philip decides he wants to save money as well. He already has $40 saved from mowing lawns over the summer. He plans to also save $10 a week from his allowance. How many weeks for Marcus and Philip to save the same amount of money? All right, so let's first start with our variables. So we have X and we have Y. X is going to be the number of weeks. Y is going to be the amount saved. Okay, those are our two equations. So let's look at Marcus first. Marcus deposits $25 as a one-time thing, and then $10 every week. So Marcus has Y equals, because Y is the amount of money saved, and he's putting away $10 each week, so 10x, and he put $25 in to begin with. Now let's look at Philip. Philip already has $40 and he's going to save $10 a week. So they both have y equals, because y again is the amount of money saved. And Philip is also putting $10 a week away, right? Money weeks. And then he also deposited a flat value of $40 to begin with, because he has $40 already. And there is our system of equations for Marcus and Philip. So what I'd like you to do is this next one. 2A says Tanya is also in the robotics club and has heard about Marcus's and Philip's savings plans. She wants to be able to buy her new materials before Philip, so she opens her own bank account. She is able to deposit $58 in her account that she has saved from her job as a waitress. Each week, she also deposits $4 from her tips. How many weeks for Tanya and Philip to save the same amount of money? Well, our variable is still going to be x is the number of weeks. And y is going to be the number, the amount of money saved. Okay, so I'll give you that much. Keep in mind we do know Philip's equations, so go ahead right now and write your system of equations, one for Philip and one for Tanya. So hopefully you remembered or found Philip's from the previous problem and wrote y equals 10x plus 40. And then if you look at Tanya's, Tanya was putting away $4 every week, and she had an initial amount of $58 already. So that is how we write systems from problem situations.